Imagine a surge of seawater rising to the top of an 18-story building. That is a vertical climb of 60 meters, about 200 feet. That volume of water is currently locked frozen inside the 14 million square kilometer ice sheet of Antarctica. This ice is up to 4.5 kilometers thick. Because it sits isolated at the South Pole, it is easy to view the continent as a distant, localized environment that has little effect on the rest of the world. But that isolation is ending. The Antarctic Peninsula is currently warming at 3 degrees Celsius, a rate 5 times faster than the global average. The release of this 60-meter vault adds mass to the sea, while simultaneously disrupting the ocean currents that regulate our planet's temperature. All 60 meters of that ice will not melt immediately. The massive, high-elevation sheets of East Antarctica remain stable for the time being. The immediate danger is concentrated in the West Antarctic ice sheet. This region is highly unstable and holds enough water to raise global sea levels by 3 to 4 meters. These photographs show floating ice shelves fracturing and collapsing. As the Southern Ocean warms, it erodes these shelves from below, removing the friction that pins the ice to the bedrock, allowing inland glaciers to slide toward the sea. This triggers marine ice sheet instability. Once a glacier detaches and crosses a tipping point, its retreat becomes an irreversible process. The collapse of the West Antarctic ice sheet is the first domino, turning a slow melt into an active oceanic crisis. While the volume of this meltwater is a visible threat, its lack of salt content creates a different, complex danger for the planet. The natural state of the deep Antarctic Ocean is cold, heavy, and highly saline. This density drives the Southern Ocean overturning circulation. As this heavy, salty water sinks to the sea floor, it acts like a pump, pushing a massive conveyor belt of currents around the globe. When the shelves collapse, they dump millions of tons of zero-salinity fresh water into this environment. This diluted meltwater is lighter, so it floats. It fails to sink, effectively acting as a brake on the pump driving the global current. By adding fresh water to the Southern Ocean, the melt physically short-circuits the engine that regulates our world's oceans. Because ocean currents distribute heat around the planet, stalling this circulation immediately impacts global weather systems. We will see severe shifts in rainfall. The Southern Hemisphere will experience significant drought, while the Northern Hemisphere faces a disruptive surplus of precipitation. This imbalance destabilizes the climate on land, specifically threatening the temperature and rainfall patterns that communities across Africa rely on. The danger is also biological. A stalled current traps vital nutrients in the deep ocean, potentially leading to the collapse of massive marine ecosystems and global fisheries. This balance of ice and circulating water has successfully regulated the Earth's climate for 34 million years. But right now, rapid, human-driven global warming is violently undoing that ancient stability in a mere matter of centuries. The 60 meters of ice in the Antarctic vault is the total volume of coolant keeping our planetary engine within a safe temperature range. If the Antarctic vault cracks, our redrawn coastlines will be a permanent reminder of a broken planetary thermostat, one that has sustained human civilization since its beginning.